Okay, hi everybody. In this short video, I'm going to be going over this assignment thread safe map. By map, we mean hash map, sometimes interchangeably known as hash table, dictionary. Some of these terms have more specific meaning, but that's not particularly important for this assignment. So, point being, we have a data structure that works well like a map. You have, in this case, strings as keys to some sort of array-like structure, and those strings are going to be used as the indexes like you would in an array, and you will get an integer back. So we'll go through the code in a minute, but for the time being, the goal here is to finish the implementation. You've been given an implementation that works sequentially. And so what it does, or the way the code currently works, is it uses this hash map to read through a set of files and count all of the words in those files. Counting the unique words in the file. So at the end of running this program, it will print how many of each word it finds. We'll look at that in a moment. So you need to use pthreads to parallelize this code so that each thread works on its own file. You'll see what that means when we open the code. And two, we're going to upgrade the hash map to be thread safe. So you're given a code for a hash map T data structure, which we want to be thread safe. In particular, we're going to use fine-grained locking to make sure each bucket has its own mutex. Each bucket is locked. And that way we can use parallelism to access lots of different parts of this hash table at the same time without locking the whole data structure. Also, main will need to be modified to use pthreads to make this process parallel, this file reading process. The code expects a test sources file, which I'll show you an example of in a moment. There are some sample files given and also some sample inputs. The hint here is that you should probably try to make the code parallel first. You can use coarse grain locking to test that the parallelism works. Once that's done, then you can start modifying hashmap.c. So this is a good idea to do first. If you try to make all the changes at once, it becomes very difficult to find where the problems are. And also the hash map should really be the only piece that you need to lock here. No other resources should be shared in a way that creates a race condition. The code presently is structured like that, so the only way this could happen is if in your conversion you share resources in a way that doesn't really work with this scheme. Hopefully it's straightforward. If it's not, then you should come talk to me. Finally, the test input files are compressed, so you should use gunzip to uncompress them. Gunzip is G unzip, the opposite being gzip. So gzip compression is what's being used here. So gunzip will unzip a gzip file. And then finally, the remaining instructions are the same as they have been for all of your other assignments. Please follow these instructions if you want your code graded in a timely manner and without possible point deductions. Okay, so let's switch over here real quick and take a look at these files so you can see that I've just unzipped the same zip file that you've been given. So if we look inside of this code, we see several files. First is test sources. We'll look at test sources first. This is the argument. You're free to change this if you want to test a smaller group of files. That may save you some time. But anyway, this is just a list of other files to read. This is the argument to your code. So, secondly, you'll notice all of those point to this books directory. In the books directory, there's a bunch of text files. that are gzipped. If you want to uncompress them, and you do want to uncompress them, you need to use gunzip star.gz to uncompress them. So let's do that real quick, just to show how it works. Ta-da! All of them are unzipped. So now we'll see that the paths match. So book / Bram Stoker's Dracula is a file in this directory. So the books work properly now. All right, so then really quickly we can take a peek at our source code. So we have a main.c. You'll see a comment here that says if you're reading this first, skip to the main stuff. That's because this code does several things that you don't need to worry about. The beginning portion of this code where it reads in this file, finds out what files contain the text documents we're interested in, that all is done for you. You don't need to modify that. So you're going to want to go down to main, which is at the very bottom. In main, we can find, there's quite a few pieces here that you're meant to improve to make it not so long, at least. That would be the main improvement, is this main function will not be as long. It will be very different. So arc parsing is checked for you. Collecting the file names is done for you. So all of your file names are going to be stored in this handy string array called files. So files contains the file names. Num files contains the number of files there are. And so the main portion of this code, which is marked with to do, this is where you're really supposed to make changes, declares a hash map, initializes the hash map, and then iterates over each file in this list. After that, it does quite a bit of stuff. It does the things that you need to do to read in a file and split it into strings. You should be relatively familiar with this kind of procedure because you've done something similar for your previous assignments. But anyway, we read in the file, we tokenize it, and we start to add these strings to our hash map. And we do this iteratively as well. We go through the entire file, add things, and then we move on to the next file. So your goal is to parallelize this process. You would like to do each file in parallel. So that is the main portion here. And then if you look at the bottom, you should really just leave everything below this line alone. There's no need to change it. If your code is working properly, then the stuff below will work. If you have an error that occurs down here, it's because you've made a mistake up here, okay? So leave this alone. If you mess with this, then we will have a much harder time grading your assignment. What this does is it just iterates through every entry and prints to standard error the name of every word, the actual word. It prints the word, and then it prints the count of that word. How many times did that word appear in the file, or in all files? So if you're doing this in parallel and you're reading 5 different documents, Val should print the sum of each word across all documents, because you're using the same map in every thread. And then finally, there's a third argument. This is mostly for me. It just looks up how many times a specific word occurs. Don't change this, but you can use this third argument to your advantage if you would like to help. If it helps you debug, you can do that. But don't change this in your final code. Okay, so that's the main summary of this code. Now, of course, you're going to have to take a look at hashmap.c. I'll leave this to you to read. You only need to understand so much of it. If you understand that our goal here is to implement fine-grained locking so that each bucket is independently locked. That is your key objective. That means you do not need to understand this code in and out if you understand how locking works and how mutual exclusion works. If you don't, you need to come talk to me, because this code does not require a tremendous number of changes to work. And as a hint, you probably can leave most components alone that are down here. You need to leave init alone. You need to leave destroy alone. We don't care if these are thread safe. Also, I've implemented some iterators for you. This is just used to print data. You don't need to modify these. These do not need to be thread safe. And then finally, there's a test function at the bottom that just tests if the hash map works, so you don't need to worry too much about that either. And then there's a hashmap.h, which contains the data structures we use, as well as all of the public functions that we use to interact with both the hash map and its associated iterator. So when we put it all together, we can just run make to build this. You'll see we're given a main executable, which is our main file. And then we will supply it this test sources.txt. And what you'll find when this happens is that I've made a mistake in the test sources.txt. So we will update that quickly in the next example. So when we remove this additional .txt, which will show up in your zip, you won't have this problem, but we remove the extra .txt that was here in this file. We try to run this again, and you'll get results that look like this. So of course, these are using a handful of special, older, different resource documents. So you may have some characters show up and these sorts of things that you're not used to. But generally, you'll have words that look like this. The script does try to remove a lot of these punctuation type characters, but there's some words that you can't do much about. So for each word that you find that just happens to be in these documents, you should get a result that looks something like this. So that is the main component of this. Your sequential code should produce, maybe not in the same order. The words may not be in the same order, but if you sorted this list, then the count for each word should be the same when you run it in parallel. You can trivially sort this if you use the sort command. So you can use this to compare your own output to your parallel version. So in summary, that is it. The code should work in parallel. It should give you the same result, more or less, but it should be faster. If we have enough files and enough parallelism, it should be faster to process all of this data and produce the same result. And as I said before, you can give it a word. So for example, I see diamonds, so we will do diamonds. And that will just print at the very end how many times the word diamonds appeared, which you can see was 101. Again, this is in standard out, not standard error, so you can use piping and things to make it, to save it to files. Output redirection and piping to save it to files or send the output to another program. So that's the summary. This is how you use the program. All of the pieces that you're given should work properly. And so your goal is just to update this to meet the assignment requirements. So good luck. Feel free to reach out if you have any questions. And otherwise, we'll see you in the next video.